Today we will be demonstrating how the Ohio DOT data format for geotechnical site investigation data can be transferred using DIGGS, and we'll do a full round trip of this data. This is similar to the video we did previously showing a round trip of CPT data, but this one contains borehole data and lab testing data. So we're first using the Kinetics DIGGS feedback tool that supports whole base, an Excel workbook, an AGS data file, and a GINT project file. So let's click on the GINT project file. We'll choose, we're using GINT Ohio. We'll go choose our source data file, and we're going to export it to this XML file. So that is a DIGGS file, that XML file. So it's going through, it's reading all the data from GINT, populating this Excel workbook, and once it finishes, we're seeing lots of different tabs: soil descriptions, samples, Atterberg limit test results, sieve analysis test results, hydrometer test results, natural moisture content test results. Basically any type of data that Ohio DOT has in their GINT file format has now been written to this DIGGS file. So the next step is to use Dataforensics DIGGS conversion tool. So we can convert a DIGGS file to either a format that is GINT or whole base. So let's go get that XML file that we just wrote. Demo data 329. There it is, written at 8:14 a.m. This is a current demo, not something recorded months ago and shown today for the first time. So we're now converting that, and you can actually see what the format is that is being provided here, just as an example. And it has finished the process, and it has actually saved a CSV file that is GINT compatible. And since GINT does not support DIGGS, that's why we use CSV. So if we import this text file, and we're going to go to that folder, there is the file we just wrote at 8:15 a.m. We need to choose a correspondence file, and we're going to overwrite everything. Few GINT error messages related to some GINT programming that apparently does not work properly in GINT. Okay, so we've got that. Let's set the depth log page as 15 feet and save that. And here you'll see we've got the borehole data, we've got all the sample data, blow counts. We don't have any drilling notes. We have water level. We have material descriptions, soil components and rock components. We have lab testing data, natural moisture contents, Atterberg limits. There's some sieve data in here somewhere with percent finers. Hydrometer data as well. And I believe that would be it. So if we go and we actually, let's generate a PDF. And I've already generated one of the exact same log. So one is called ORG, the second is called RT for Roundtrip. We're going to overwrite that, and we're going to open that up. So once again, it has finished generating that log. You see we get 3 pages of a log report. So just for reference, I'm going to open the original PDF. So here's the original, and you will notice 2 very minor differences between the original and the round trip. Let's actually put them this way. So here's the original, and in full disclosure, there are 2 pieces of data that are not DIGGS compliant. The first is this sample ID, which is improperly labeled. It's a specimen ID. And the second is how the backfill is being managed within GINT. It's not data. So if we compare this with this, you will see a little flicker. This column changed, this column changed. Everything else on the report is identical. We can do the same thing on page 2. Page 2, go back and forth. You'll see this column flicker, this column flicker. Third page, same thing. So other than that, other than the data that is not DIGGS compliant, the round trip of the data has been completed.